Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining about the case studies. Case studies means three different types of software application we are going to discuss in this video. So first I will discuss a insulin pump control system software. Second I will discuss a patient information system for mental health care software and a weather station software. A wellness weather station software we are going to discuss lastly, right? So case studies are nothing but software application example. If you are not subscribed to my channel, please subscribe to my channel and don't forget to like and share the video. So let me begin the explanation of the first case study, a insulin pump control system. So a insulin pump control system is a embedded system. Embedded system means this is a software, right? This is a software mainly used to control a hardware device. Very simple. Embedded system means embedded system is a software. It is a set of hardware and a software. So the software is mainly used to control the hardware component, right? Now a insulin pump control system is a medical system. Medical system means insulin pump. You can see that insulin pump is a hardware. Insulin pump is a hardware. I'm going to develop a software to control that insulin pump. Now, insulin pump, what is the task of the insulin pump? Insulin pump is mainly used to treat the diabetes patients who suffer from the diabetes, because diabetes when it will arise means if your internal organ pancreas, it doesn't work properly, it doesn't produce insulin properly, then you have to inject the insulin to the body. So our insulin pump system is used to inject the insulin to the body of the diabetes patient. Getting, guys? So as you all know, this insulin pump control system is a embedded system. That means the software is mainly used to control the hardware, right? So if I say a insulin pump control system, it contains a sensor, right, and it contains a pump, all those hardware components, right? Because you need to control the dosage of insulin, right? That's why you need a sensor and all those things. Now we will discuss this insulin pump control system in a more detailed way, right? First of all, so you should understand the diabetes disease. Then you can easily understand how this insulin pump works, right? People who suffer from diabetes use this system. First thing is, people who suffer from diabetes will use this system. So now diabetes is what? Diabetes is it's a condition, it's a disease where the human pancreas is unable to produce the sufficient quantity of hormone called insulin. The hormone insulin should be in a balanced, right? In a balanced way. It should be there in our body in a balanced way. When it is unbalanced, then you suffer from a disease called diabetes, right? And also I can call it as a glucose. Insulin metabolizes glucose in the blood, right? So how to treat this? The conventional treatment of diabetes involves regular injections. So I have to take the regular injections of insulin to treat the diabetes and to maintain the proper level of my insulin, right? Diabetics measure their blood sugar levels using an external meter and then calculate the dose of the insulin they should inject. So how this system works? So first we will calculate the blood sugar level using the sensors, using the external meter. Next, once we are sure about the amount of insulin, then we can give that amount of insulin to the patient. This is the simple working, right? Now we will see. So the problem with this treatment, some problems are also there with this treatment. What are those problems? The problems with this treatment is that the level of insulin is required does not just depend on the blood glucose level, but also on the time of the last insulin injection, right? Getting, guys? So you should always take care of the time also, the amount of insulin you need to inject. Along with that, you have to consider the time. When is the last time the insulin is injected? That is very important. Suppose if insulin is injected 5 hours ago, then the dosage will be different. If insulin is injected 2 hours ago, then the dosage will be different, because you have to maintain the balanced level of insulin, right? That's why. So if you are careless about this, what happens? This can lead to very low levels of blood glucose if there is too much insulin. If you inject more insulin, so it will lead to the low level of blood glucose, or very high levels of blood sugar if there is too little insulin. Getting, guys? It should be balanced, right, injection of insulin. And one more important thing, low blood glucose in the short term a more serious condition. It is a more serious condition compared to the long term, that is high blood glucose, right? So low blood glucose level may result in the temporary brain malfunctioning and ultimately unconsciousness and death. More serious problems can be happened because of low blood glucose level. In the long term, however, continual high levels of blood glucose can lead to eye damage, kidney damage, and heart problems. Getting, guys? So you need to maintain the proper level of insulin, right? So here today, to take care of those things, to properly measure the insulin, right, we are developing some sensors, right, and automated insulin delivery systems also are in development, right? So this system, they will monitor the blood sugar levels and deliver the appropriate dose to the patient. Getting, guys? So this is the working of our insulin system. So you can see here, this is the components of our insulin control system. So we have a needle assembly, insulin reservoir, that means it contains the insulin. This is one component. Needle assembly. So needle assembly will be there. Needle assembly contains the needle, right? Pump will be there to pump the insulin to the needle assembly. Along with that, to measure the insulin level, we have a sensor, right? Controller. Alarm is there. If insulin is low, then it will then it will make a sound. If insulin high also, it will make a sound. For that purpose, we have a alarm. Along with that, we have display to display the sugar level, to display the amount of insulin, right? We have a user has to see those things, right? That's why we need a display, LCD display or a LED display. So these are the component. Insulin reservoir contains the insulin, needle assembly contains the needle, pump is used to take the insulin and to inject to the patient using a needle assembly. Sensor is there to measure the sugar level. Controller, this is the main component. The controller maintains all these sub-components. Clock is there. Yeah, clock, time. You need to check the time also, right? That's why you have clock also, alarm also, and display, LCD or LED display. More importantly, along with that, you have to use power supply, right? Power supply. Getting, guys? So these are the components. So how it works means very simple, right? You can see here. First, we will see this now. See here. So figure shows the hardware components. You know that. So that the insulin pump delivers 1 unit of insulin in response to a single pulse from a controller. Getting, guys? Therefore, to deliver 10 units of insulin, the controller sends 10 pulses to the pump. So getting, guys, how it works means the controller has to send the signal to the pump. If controller sends 1 unit, single pulse, if a controller sends single pulse, then it will assume that it is a 1 unit. Therefore, suppose if you want to inject 10 units of insulin, then the controller has to send 10 pulses to the pump. Getting, guys? Getting? You can see here a software controlled insulin delivery system might work by using a micro sensor embedded in the patient to measure some blood parameter. See, sensor will be there, So it will be embedded in a patient, right? So you can see, so it will be embedded in the patient. So sensor will measure the blood glucose level. So this is the first step. Sensor will measure the blood glucose level. Next, what happens? This is sent to the pump controller. So the sensor data will be sent to the pump controller. So controller, what it does? So next, what it does? This controller computes the sugar level and the amount of insulin that is needed. So it computes the sugar level and also the amount of insulin that is needed. So controller will compute that, the amount of insulin it will compute. Next, what it does? It then sends the signal to a pump to deliver the insulin through permanently attached needle. Getting, guys? So controller, once it's calculated the amount of insulin, it will send the signal to the pump to pump the insulin to the patient using the needle that is attached to the needle assembly. Very simple working this is. Getting, guys? First sensor will calculate the amount of blood sugar level, right? So it will that data will be sent to the controller. The controller will compute the amount of insulin that is needed to give to the patient. Then it will send that data. Pump will take the insulin from the insulin reservoir. That the amount of insulin that is needed will be taken by pump from the insulin reservoir, and it will be sent to the needle assembly to give it to the patient where the needle is attached. Getting, guys? Very simple working. So I have to write the software for this. Getting, guys? So and this is the active model of the insulin pump. Active model means active diagram. In the design phase we use this models. You will come to know about design, all the high level design, low level designs in the coming session. But here you should know this activity model is nothing but it will show the in detail working of the insulin pump. So you can see here this filled circle is the start state, and these two circles, one is filled circle, one is the hollow circle. This is the stop state. So you can see there. So this is the complete working. This activity model is showing the complete working. First, blood sensor will sense the blood, right? It will analyze the sensor reading. It will analyze the sensor reading. It will take the blood and it will analyze the sensor reading, and it will calculate the blood sugar level. Once the blood sugar level is calculated, and you can easily compute the amount of insulin that is needed to the patient, right? After computing the amount of insulin, it will log that. Log that means it will store that information. Suppose if a user wants to see that information for the next time, how much insulin he took. If suppose he want that information will be there in the insulin log. So once the insulin is computed, the amount of insulin is computed. So insulin dose, you can see that insulin is amount of insulin is sent to the component called insulin dose. The dose is sent to the amount of insulin dose is sent to the pump. Along with that, amount of insulin data is also stored in the log. Log means for future use. So once the insulin dosage enters the pump will send that to the needle assembly. Data to the needle assembly. You can see there. Control insulin pump means that are the commands to control the pump. Your pump has to control the needle, right? It has to move the needle, right? So those things. You need the commands for those things. Getting, guys? This is the overall working. This activity model shows the working of the insulin pump. So start state, stop state. Getting, guys? Very simple. Hope you are understanding the things. If you have any doubts, please post your doubts in the comment section. Right? See, this is the UML activity diagram. So if the pump fails to operate, one of the important thing here, see here, if the pump fails to operate or does not operate correctly, then the user health may be damaged. Yes, definitely. Pump should operate properly here. If a pump is not operating properly, definitely it will affect the health of the user. Getting guys? That is very important. Therefore, you have to consider two essential requirements, very high level requirements. What is that? The system shall be available to deliver insulin when required. That means it has to work around the clock. It can't stop. This is a life critical equipment. Life critical means this is directly related to the right health of the patient. That's why this is a life critical equipment. The system shall be available to deliver insulin whenever required. All the time it should be available, and the system should perform the operations correctly. It should give the correct amount of insulin, right, without any problem. So while developing this type of system, you need to be extra careful, because this is a life critical system. Not only this, for example, missile systems, that is also life critical system, because if a missile misfires, then definitely it will cause a huge loss. In the same way, if this insulin system doesn't work properly, it will cause death of the patient, right? That's why you should be extra careful here. Getting guys? So the first case study is over. So the first case study is what? Insulin control system. That is a embedded system. That means the software used to control the hardware device. There my hardware device is what? Pump, insulin pump. That is one type of software application. In the second case study, we were going to discuss another type of software information, and this software task is different from the first software application. So the second category is the information system. First category is the embedded system, and the second category is the information system. So this is a system whose primary purpose is to manage and provide access to database of information. Now you can ask a question, sir, what is a database? Database means you are going to store your information in some place, right? That is nothing but a database. Database is going to collect the data from the user, or database is going to collect the information from the user, and it's going to store it. This is the example for information system. Getting guys? So this in this information system, I'm going to discuss about the medical record system. Getting guys? This medical record system is going to store the medical records of the patient. So this is the example of an information system. Now we will discuss that medical record system in detail. So this is the second software example. This software is going to store the patient information of a mental health care, right? A patient information system to support mental health care is a medical information system that maintains information about mental patients that are suffering from, those who are suffering from mental health problems. Along with storing the patient data, this software is also store the treatment details also. It's very simple software. It stores the information of the mental patients. Along with the mental patient, it stores the information of the mental patients. It stores the information of their treatments also, right? So mainly this software can be used in mental health clinics. Getting guys? Very simple software. See how it works. This software, mental health care software, uses a centralized database of patient information. Centralized database means the software can be accessed by different people. Centralized means right, see here, if a patient wants to access it, he can access. Receptionist, she can access. Doctor, he or she can access, like that. Centralized, anybody can access this patient information system, and this software can run on a PC, so that it may be accessed and used from sites that do not have secure network connectivity. Even if it is not a secure connection means VPN, right? Even if it is not a secure connection, no problem, this software can work without any problem. Getting guys? So here I'm maintaining a centralized database. Centralized database means data will be maintained in a single place. All the other people can access the data that is maintained in the single repository. You are going to maintain your data in a single place. Very, very important. Getting, guys? So when the local system have secure network, they use the patient information in the database, but they can download here. If you want, you can download the information also. You can download the copies of the patient records. Even if there is internet, even if internet is not there also, no problem. You can download it and you can store it in your PC. And along with that, the system is not a complete medical record system, right? Along with that, it will maintain some other medical data also. Getting, guys? So first thing, it makes use of a centralized database. Centralized data means you are going to maintain only one copy. The same copy can be accessed by doctor also, receptionist also, patients also, right? Any number of users can use that single copy. It will be there in the database. Anybody can see that, no problem. And even if it is not network connectivity is not there also, it can work. You can download the patient records without any problem. And along with storing the patient records, it will store some other extra informations also. It is designed in such a way that to store all the other informations also along with medical record system, right? Getting, guys? So this is the diagram of this mental healthcare patient management system. You can see server is there. Server means where the data is stored, patient data is stored, right? Server stores the patient data. So MHPS local means this is my for example, see, this is consider that this is a receptionist system, consider that this is a doctor system, consider this as a patient system. Getting, guys? All the three can access the same copy that is there in the server. See, server maintains the patient database. I don't want to confuse, guys. Don't get confused. See here, very simple. Your data will be there in the server. Anybody can access using their personal machines. Getting? So, and one more important thing, the MHC PMS has two overall goals. What are the goals of this mental health care patient management system? To generate management information that allows health service manager to access performance against local and government targets. I told you, it is not going to store only the patient information. It will store all the other information that is needed by the health service managers and also by the management. Hospital management need patient data to see how many number of patients are recovering and what is the recovery rate. Those things they can see that, right? Hospital management, hospital owners can use this software to see those informations. Not only patients can use this, hospital management also can use this. Along with that, medical staff can use this. Why? They can check the schedule of the patients, whether they are taking the medicines properly, whether they are coming for the treatment frequently. Those things the medical staff can check with this database without any problem. Getting, guys? Along with storing the patient information, you can this information can be used for doing these things also. Getting? Suppose if you have any doubts, please post your doubts in the comment section. And users of this system, this mental health care patient system can be used by clinical staff such as doctors can use this, nurses can use this, health visitors. Health visitors means nurses who visit people at home to check on their treatment. They can also use this, right? Along with that, non-medical users, not only doctor, nurses and health visitors. Non-medical users can also use this. Who are those? Receptionists to make the appointments of the patients, they can use this. And medical record staff, I told you, who maintain the record system, to maintain the records of the patient, they can use this. Administrative staff to generate the reports, to generate the amount of fees, those things, medicine fees, those things they can use. Those things can be calculated and used by the administrative staff. Getting, guys? These are all the users, those who can use the mental health care patient system, patient management system. Next, and along with that, the system is used to record information about patients. You know that, right? Obviously. So, and also reports are generated at regular intervals. Obviously, reports are generated at regular intervals. More frequently, you have to generate the reports because you have to monitor the health of the patient, right? That's why. And what are the key features of the system here? What are the key features? Right? Very, very simple. Don't get confused here. Individual care management. Individual care management means what? Clinicians, clinicals can create records for patients, edit the information in the system, view patient history, etc. Individual information can be stored without any problem. That means individual patient, single patient, separate patient details can be stored separately without any problem. And also not only you can store, you can edit that, you can view that, those things, right? And the system support data summaries. So the doctor who have not previously met a patient can quickly learn about the key problems and treatments. What is the advantage here? So suppose if a new doctor is joined to the hospital, he can quickly use this system to know about the patient, right? He is a new member, no worries. You can quickly use this database, you can learn about the patient, you can learn about the treatment of the patient. Those things will be done here. Individual information can be stored without any problem. Individual patient information can be stored without any problem. Next, what is the next key feature? Patient monitoring. You can monitor the patient progress. This system regularly monitors the records of the patients that are involved in treatment. Why it monitors means it is to issue warnings. Why it issue warnings? If possible problems are detected, if any problems are detected in the patient, the system can issue warnings to the patients. Therefore, if a patient has not seen a doctor for some time, a warning may be issued. He can come to a hospital once the warning is issued, right? So you can keep track of your patients without any problem. You can give the treatment in a right time. Getting, guys? This is the second key feature. Administrative reporting. I already told you. This system can be used to generate the reports for medical management to use that report, right? The system generates monthly management reports showing the number of patients treated or the number of patients who have entered and left. Why? They can calculate this. Hospital management can calculate the profit or it can calculate the loss, like that. They can use this, right? And also along with that, very, very important, this system has to take privacy and safety requirements very importantly, because it is storing the patient information. So patient information is private, so security plays a very important role here. The system must be available when needed. 24/7 it should be available. Otherwise safety may be compromised, right? I can't guarantee the safety if it's not available 24/7. That's why it should be available 24/7. And privacy, you should give the privacy. Only who is having the proper username and the password can see the information. Otherwise it should not be allowed. He or she should not be allowed to see the information. Getting, guys? So next key feature, right? So far we have discussed about the two different software applications. So first one is the embedded system, second one is the information system, and the third one is a different type of system. It is a sensor based data collection system here. So a sensor based data collection system, this is a system whose primary purpose is to collect data from a set of sensors and process the data in some way. This software is going to collect, in this context system and software are not the same, don't get confused. This software is going to collect the data from the sensors. Here this is sensor based software. To explain this, I am going to consider Wilderness Weather Station. So what is this software actually? See here. So this is a weather station software. So this software used to help monitor climate changes. This software is used to monitor the climate changes. That's why I need sensors temperature sensor, wind sensors, those things, rain sensors. So I need the sensors to monitor the climate change. Why I have to monitor the climate change? Because to improve the accuracy of weather forecasts, to improve the accuracy of weather reports. Where? In remote areas. Wilderness means especially in forest areas. For example, assume that our government wants to track the climate of the forest, right? They can use this software. They can deploy this software in 100 of places and in a remote places especially. Why in a forest area? Forest area means transportation problems will be there. No one, the transportation problem can be avoided if you install this software in a forest areas, right? That's why. So what this software does, these weather stations, when you install this software, these weather stations in different places, this weather station can collect data from a set of instruments. I already told you it is mainly used to sense, or it is mainly used to measure the temperature, pressure, sunshine, rainfall, wind speed, wind direction. So I need sensor. It will collect all this data and it will give the data to the concern to predict the climate changes in the wild areas, especially forest areas. Getting? See, this is the diagram. Here you can see here. Here this software is a collection of 3 components. What are those? Weather station is one component, station maintenance is one component, data management and archiving is one more component. So this total software is a collection of 3 different components. Don't worry about the syntax of this diagram. So you will come to know about this in the coming sessions. So weather station, data management and archiving, station maintenance. Now we will discuss this each component in detail. See, this software, this wilderness weather stations, we are going to use this software in weather stations, right? So this software contains these 3 components. See, the weather station system is the first component. What is the task of this component? This is responsible for collecting weather data. Yes, this weather station system, this component of the software is going to collect the weather data. It can carry out some initial data processing and transmitting it to the data management system. So the weather station system collects the weather data. After collecting the weather data, it will send that weather data to the data management and archiving system. The data management system, what it does means, this system collects the data from all the weather stations, because you know that I can install this weather station in hundreds of places. That's why there can be a lot of weather stations. So the data management should collect the data from all the weather stations, and it can carry out some processing and analysis, those things, right? It will do the analysis because it has to predict the weather, right? That's why it will do the analysis, the data management system. And archives the data. Archives means it will store the data for the future purpose also, right? If other system wants this data, you can store the data, you can archive that data, they can use that for a future. Getting, guys? To predict the weather, you need some old data, right? That's why you can use this data for the future predictions, right? Whereas other new weather stations can use this data, right? Getting, guys? And the last thing, the station maintenance system. This system can communicate by satellite with all the weather stations. Yes, this maintenance, because if station is not working properly, if any problem arises, the station maintenance system is responsible for correcting that. Weather station, all the weather stations should communicate with the station maintenance system, because this station should monitor the health of the systems, weather stations. If everything is fine, no problem. If anything happens, it should report that to the data management and archiving system, right? That's why you have to monitor all the weather stations properly. And the station maintenance can be also used to update your software also. If any problems are there in the system, you can update that and you can correct it. And also, and one more important thing, you can remotely do all these things without any problem. You can sit anywhere and you can do all these things without any problem. Getting, guys? So far we have discussed 3 different types of case studies, that is 3 different types of software application. First one is embedded system, mainly used to control the hardware device. Second one is the information system. Information system means mainly to store the data and to write and to retrieve the data. And the third one is the sensor based software. Mainly it's going to collect the data from the sensors and it's going to process it. Getting, guys? So hope you understood the concepts. If you have any doubts, please post your doubts in the comment section. Thank you for watching the video.